How do periods on the periodic table work? Imagine a giant chart filled with all the elements that make up everything around us. This chart is called the periodic table. Now, the rows in this table are known as periods. But how do these rows work? That's what we're about to find out. Periods are the horizontal lines across the periodic table. Each one shows a set of elements that share something special. The key is in their electron shells, which are layers of electrons around the atom's nucleus. The first period has only two elements, hydrogen and helium, because the first electron shell can hold only 2 electrons. The second and third periods each have 8 elements because their shells fill up with 8 electrons. The fourth and fifth periods have 18 elements, and the sixth and seventh have 32. This pattern depends on how electrons fill different orbitals inside the shells. As you move from left to right across a period, the number of protons in the nucleus increases by 1 for each element. This means the positive charge in the nucleus gets stronger. Because of this, electrons are pulled closer to the nucleus, changing how the elements behave chemically. On the left side of a period, elements tend to be metals, which are shiny and good conductors. Moving to the right, elements become less metallic and more like nonmetals, which are often gases or insulators. The length of each period varies because of how many electrons can fit into the different shells and subshells. The first period is short with only 2 elements. The second and third are longer with 8 elements each. The longer periods, like the fourth and fifth, have 18 elements, and the sixth and seventh are even longer with 32 elements. These longer periods include the filling of more complex orbitals called d and f orbitals, which add more elements to the table. Understanding how periods work helps us see patterns in properties like atomic size, which gets smaller across a period, and electronegativity, which is how strongly an atom pulls electrons towards itself. For example, elements on the right side of a period tend to attract electrons more strongly than those on the left. This pattern helps chemists predict how elements will react and bond with each other. Knowing about periods makes it easier to understand the behavior of elements in everyday life. It explains why some elements are good conductors, why others are gases at room temperature, and how elements combine to form everything from water to plastics. The organization of the periodic table reveals the structure of atoms and shows how the properties of elements change in a predictable way across each row. This system helps scientists and students alike make sense of the building blocks of the universe.